Hello and welcome to U plus AI's YouTube channel called Startup Reports. I am Ranga, and in this channel, I review products and solutions from startups at the intersection of healthcare and artificial intelligence. I am doing a COVID-19 special series now, where I'm looking at solutions from startups that help in managing various aspects of infectious diseases and pandemics like COVID-19. In this episode, we will understand more about the DETECT study. Let's get into it. So what is the DETECT study? Now, before we get to the DETECT study, let's understand the background of where the DETECT study came from. It actually came as a consequence of this paper in the LANCET, which is a medical journal, the LANCET Digital Health. And the paper is titled Harnessing Wearable Device Data to Improve State-Level Real-Time Surveillance of Influenza-like Illness in the USA, a population-based study. Now, what is the background of this paper? The idea was that medical research has proven that individuals who have an acute infection show an elevated resting heart rate. And the other observation is that many of us who wear wearable sensors, like the Fitbit band or the Apple iWatch or different other trackers that people wear today commonly and that give you information about steps, about your heart rate, about your sleep and all that, they give information, they collect this RHR data, that is the resting heart rate data, and also the sleep data. Now, if you put these together, that's what got the researchers interested, and they had a purpose to say, if we could collect such data at a population level, at a large scale level, then could it really help us determine whether there are influenza-like illnesses in such a population, in such a geographic population, in a community or not? So they set about trying to understand whether their hypothesis was true. So for that, they conducted a study. And in this study, they took the wearable sensor data from around 200,000 individuals in the USA. And this study and this data was from March 1st of 2016 to March 1st of 2018, so about 2 years of data. And this data was largely concentrated around 5 states in the US. Of course, they had to do a lot of data cleaning because many times when we get this data, much of the data is noisy, or sometimes the data is missing, or perhaps people are wearing the wearables but they're not wearing it for enough time to record the data properly. So if you look at the paper, they give you a complete understanding of this data, what they had to discard and how much they had to really work with in terms of the data. But they did work with it, they did model the data with the idea of predicting influenza-like illnesses to a greater degree, to a greater accuracy. And their finding was that they were able to predict the influenza-like illness more accurately. And then the accuracy went up from 6.3 to 32.9%, depending on the geographic region or the state in the USA that you considered. And of course, this was when being compared with baseline models. So again, the ground truth data was really, I think, data reported by disease agencies like the Centers of Disease Control in the US. So they were able to say that with this data, they were able to predict this well, such that it was closer in line with the actual ground truth data that occurred during that time. So what did this mean for the researchers? So what this meant for the researchers is that there is some validation of their hypothesis, and so they decided to launch a further study, right? Further collect data. So let's look at what that is. So this is basically called the DETECT study, and what this means is that basically they launched an app called the My Data Helps app, which is available in the App Store as well as in Google Play. And how each one of us can participate in the study is that we download that app and we contribute to the study by giving access or by contributing our resting heart rate data and sleep data to this app. Now, of course, we don't have to enter it. Once you download this app, it asks us consent to basically use this data. And once we provide the consent, this data is automatically used, over a long period of time. Of course, this app also provides us with the ability to record our fever or coughing when it occurs, right? That is something that we have to manually input. But otherwise, the base data is taken automatically from our phones, right? And of course, if you're wearing some wearables, this data is synced from the wearables to our phones. Now, this supports a wide variety of wearables, not just Fitbit or iWatch, but several other makes and several other wearables which collect this data can sync with this app and contribute the data there. So why, how does it all add up? The hope is that, just like we saw in the previous research paper, that the hypothesis that you could collect data, when you collect data over a large population, you are able to predict the occurrence of influenza-like illnesses. This means that when they collect this data, let's say for the next year or the next 2 years and all, I think the hope is that we'll be much more prepared when the next viral outbreak happens in any region, perhaps in the US or elsewhere, because this data will show that probably there is an outbreak that is happening, or even if an outbreak has happened, if it is spreading quickly within a community, we will be able to get the right signals. And of course, as we have seen with COVID-19, especially in a pandemic or an epidemic-like situation, speed is key. The earlier we know something is happening, the cost of that can come down drastically. That is, we can save a lot of people, we can save human lives, we can save the economic damage, provided we act fast. So I think that is the whole idea of the study. So what's my take? Well, this is a real interesting case of where wearables data can help in social good as well, besides just individual health. Now, of course, I wear these sensors and it helps me understand my own heart rate, my own health, how much I'm walking, how much I'm running, how much I'm sleeping and all that. And that is really good for me. But this takes it a step further, saying on aggregate, if such data is taken, I think in the future we will see even more such data. Like it could possibly be like continuous body temperature or my blood pressure, my oxygen saturation level with the help of an oximeter. Now, all of this, when taken together, I think it's a really good use case to say that aggregate data can help in social good and help in predicting outbreaks early, to help the community, to help the country, to help everyone across the world. Another take of this, which is very interesting for me, is that when you combine wearables and the fact that they can sync data to the cloud, and you can use your prediction algorithms to understand what the data is saying, telling you, this also means that there are many regions in the world where you may not have a very high tech or a very advanced laboratory, which can understand, which can do take a lot of the testing samples and tell you whether there's an outbreak or not. There may be even regions where human surveillance may not be possible. Think about developing countries, right? So if there is an outbreak happening in a remote village of a developing country like India, how are you going to know? How soon is the information going to travel? At the same time, if you take a country like India, the mobile phone penetration is excellent, right? I mean, mobile phones have penetrated to every nook and corner of India. So, and in the future, we may see that many of these sensor technologies may be inbuilt into the phone itself, or at best it could be a bracelet that somebody could wear, a band somebody could wear. And because the bandwidth is there, this data is getting uploaded to the cloud. So which means that even in areas where I have difficulty doing human surveillance or laboratory tests, this kind of a methodology could give me an early warning of where the outbreaks are happening or what kind of illnesses are really being reported. So I think this would be a very key advantage, especially in remote areas of the world and probably in developing nations of the world. So thank you. I hope you enjoyed that perspective. If you did, please like my video in the YouTube channel. You can connect with me, Rangaprasad Sampath, on LinkedIn. Also do follow my handle U+AI on Twitter, SoundCloud, and Medium. Enjoy. I'll see you again in the next episode.